Okay, here we talk about Numpy array dimensions and slicing operations. Slicing means to select data from the array, and dimensions are characteristics of the array. Okay, the simplest array is one that is just like this here with one dimensional. We have bracket, that's the outside, then 1, 2, 3. There's 3 elements in this array. So if we we create the array like this, np.array, then put the array inside of it. Then we can print it out. Here it is. It prints it out like this. Array 1, 2, 3. Now we can use the ndim function. That says how many dimensions does it have? Okay, it has 1. Now, this is interesting. Shape. Okay, shape is the number of elements along each dimension. Okay. You can think of this one as having 0 dimensions. Change that to 0 dimensions as it puts 3, 0. Now, what does 0 mean? It's hard to picture. Well, if we change it to something like this, which is arrays, 3 arrays of size, well, 0 within 1 array, then we get the shape 3, 1. See? Now, this might be how you could represent a vector. A vector in mathematics means an array with just one dimension. No, it's not always possible or a good idea to look to mathematics to understand Numpy because there is some differences, but it does help you understand. See, we take this array here, we can turn it on its side like this to more easily understand it, right? Because when you look at it in math, for example, in linear algebra, then it's stacked up like this as a vector. Okay, now, when you're dealing with 2-dimensional arrays, you can think of those as row-column pairs. Makes it easier to understand. The rows here, line these up straight, is the elements 1, 3, 5. The columns are, and then the second row is 2, 4, 5. Change this to a 6. And then we can see how many dimensions a Numpy array has by counting the outermost. See the outermost. The outermost contains something inside of it. But what does it contain inside of it? It contains 1, 2, 3 arrays. So let's see here. Let's print this out. And we have here, it just basically shows what we created. We ask it how many dimensions it has. It has 2. Then we ask it what shape it has. Okay. Why is the shape 3 here? It's because there's 3 elements in the outer array. Okay. And then in the inner array, there's 2. Right? So we have 1, 2, 3 elements that have 2 in each of them. Okay, here's another way to understand it. We could turn it around. See, up here we had like going up and down 3 things. Here we will say going across 3 things. Now this thing here has shape 2, 3 because we have 2 elements in the outer array. And each of those in the inner array has 3 elements, right? The outer array has 1 thing here, another thing here. That's the shape. In other words, remember the definition. It's the number of elements along each dimension. That's what shape means. Now with the 2-dimensional array, the shape, the first shape number corresponds to rows, and then the second one corresponds to columns. So 2 rows, basically, and 3 columns. Okay, now let's make a 3-dimensional array. Now back to mathematics again. You can think of the XYZ coordinate system. Let's look up a picture of that XYZ coordinate system to help you understand. Let's look at this picture. See? It's not drawing it the way I want it to. This, you can understand it like this. I like to put the Z pointing out, the X going across, the Y going up. But anyway, so a point out here will have coordinates, 3 coordinates, X, Y, Z coordinates. So it's a point in space. You can think of it like that. The 2-dimensional system, the row column system, is analogous to the Cartesian plane, which is just the XY system that you see in regular algebra, right? 3-dimensional is multivariable calculus. Okay. Go back here. Now look at this. See if you can understand this. Remember what I said. Count the outer ones. 1, 2, 3. So we've got 3 levels of indirection, 3 dimensions, right? Now I made this have shape 3, 3. So we'd have 3 dimensions and 3 elements along each dimension. So it'd be easy to understand. Now, when you talk about shape in a 3-dimensional array, the first element you can call depth. The second one's row. The third one's column. So look, what do we got here? See, here we've got a 2-dimensional array here, right? Why? Because look, you got 1, 2 outermost items. And then each side, each of those is just a 1-dimensional array. Okay. Now, how many of these 2-dimensional arrays do we have? We have 1, 2, 3. So everywhere we go, or here we just ask it to print it out. There's 3 dimensions, and there's everywhere we go, there's 3 of everything. So the shape is depth 3, row dimension 3, so 3 rows, and 3 columns. Now, when we're making arrays up top, we just type the numbers. There's automatic ways to create arrays, which is what you want to do most of the time. So here we can use the random integer function. Now we could say, let's create an array of size 7 by 7. See, that's the third argument here of integers randomly generated, drawn from the range 1 to 100. So here we go. Here's our resulting array. So it has 7 rows and 7 columns. Okay, now we talk about slicing. Remember, slicing means to take a subset. For example, look at this. Okay, here's the general format. If you have a 2-dimensional array called A, then the slicing works like this. You say from something to something, and you put a colon between the from and the to, comma, next dimension. So here we say from row, say 0 to row, say 5, and then from column 0 to column 5. Now notice I say 2 plus 1, because you remember you start numbering at 0. So the first element's not 1, it's 0, and the last element's not 5, it's 4. If you want to get from 0 to 4, you put 0 to 5. Here, we'll see that in a minute here. Okay, so here we say, okay, we want to get the 1, 2, 3, fourth, and fifth row here. Here we say what rows. Index 0 to 4, right? Not 5, it's 3, 4. And then this colon means all, so all columns. So we get the fourth and fifth row and all columns. Go back here and see 1, 2, 3, 4, 5. That's this area. That's a slice. It gets a subset. Okay, now let's get all rows. See how many rows are there? 1, 2, 3, 4, 5, 6, 7. I mean, how many? Yeah, how many rows? And how many columns? We get columns 4 to 5. Go up here and look again. Here, 1, 2, 3, 4. See, 4950 is at the top. 4950. Okay, now let's make a new array. Use the linspace function, which just says, put out numbers ranging from 1 to 16, and we want 16 of them. We could range it from 1 to 100 and have 10 of them. Something that's a multiple of the other thing. Okay, now we can write it like this, but we can also write it like this. We want the shape to be 16 nothing. See, there it is. There's the shape. Let's see what it looks like. Print out A here. Let me run this first. A. There it is. Now, one thing, notice it's got decimal points. So let's make it be as type numpy dot 8-bit integer. Do it again. Run out here. We just have integers. Notice it says data type. What we had before was floats. Okay, anyway, so here, the point here I want to illustrate is how to print every other element. So you say from, to, and then you say step. So this is how we can print every odd number. Let's see here. That should be now integers. See? So we start at 0, we go up 2, and then go up 2 more. So we get 1, 3. Right? We could print multiples of 5, multiples of 2, anything like this. Okay, now, there's different ways to write the same thing. We've been writing this. We've been saying some array go from A to B. In the row, comma, in the column go from C to D. Well, you can also write it like this or like this. Now that looks a little strange unless you just think of it as a two-step process, right? All right, now, our A array has 16 elements. So we can reshape it into anything that is together multiplies to be 16. So we can reshape it to be a 4 by 4. So here we go. So we have 4 rows, 4 columns. Okay, now let's use the notation we have been using. We say, okay, let's get rows 2 to 3 and columns 2 to 3. There you go. Prints it out. Now we can think of this doing it the same way here. Like, let's see, let's make it easier to see like this. See, this does the same thing. But what is it doing? Well, first it's doing this. See, which is all columns. And then we take that and then we do the second part of this against that object, right? That same object, that has, what it has, 2 rows. So now let's take the second and third columns of that, see? It just looks a little confusing, but it's the same thing. Now here, the asterisk, what does that mean? Instead of writing, A from 0 to 5, we can just put *5. Just shorthand notation. That's all. Okay, negative sign means go right to left. Now, one good thing about it is it's easier to understand in that you don't have to remember that 0 is 1. So we say -4. In a one-dimensional array, it'll just go 1, 2, 3, 4. And print out the 50. Okay, now let's go back and look at our three-dimensional array again. Print it out again here so we can see, right? Okay, now the slicing operation here will be harder to understand. With a three-dimensional array, you would probably reshape it to something easier to work with when you're using it for machine learning and stuff. So consider this an academic exercise. Although with machine learning, you usually have hundreds of dimensions, right? Because arrays are linear algebra, matrix multiplication, and we are normally dealing with independent variables, and we're going to have more than 3, right? Any interesting machine learning problem will have lots of dimensions. Okay, anyway, so now this first operation gets this gets the first row and column in each of the outermost arrays. So it's going to be this one row column, right? Remember, in a two-dimensional array, what's 0, 0? What's this thing here, right? But what we're saying we want all of is the first thing. Remember, the first thing is the outermost. So it's depth. It's 3 by 3. So it gives us the 1 from this first array, the 1 from this second array, and the 1 from the third array, since that column means get all. Now, what about this? C : comma, 0. Okay, this gets all rows in the first column from 3 of the outer arrays. Remember, the only difference is here we got a colon and here we had a number. So it's going to do the same thing. It's going to get 147, 147, 147. Okay. Now they're not stacked up and down. We'd have to rotate rows and columns to get that, list them across, right? Now, the last thing here is if we tell it C 0, 0, 0, it's going to get the first element in the first depth row and column. So it's going to be 1. This guy right here. Okay, well, that's it. Hope it was helpful. And talk to you next time.